Hello, welcome to this video about the Moivers theorem in further mathematics of Cambridge. I'm going to discuss an example number 1. So, let's try to look at this example. This is taken from Winter 2012 question paper 1 variant 1 question number 6. And it says, use the Moivers theorem to show that cosine 4 theta is equal to 8 cosine to the 4 theta minus 8 cosine squared theta plus 1. So before I go on to the next question, let's try to do first that initial part of the question. So what we're going to do is try to look at this summary here that I have. So according to the Moivers theorem, if you have z to the n, it's e, and your z is cosine theta plus I sine of theta, and that is actually equal to the z to the power of n is equal to the cosine of the power times the angle plus I sine the power times the angle. And we have shown before that the z plus z to the negative 1 is equal to the 2 cosine theta. The z minus z to the negative 1 is equal to 2I sine theta. Now, so let's try to look at this question. It says the cosine of 4 theta. So which of these equations will give us that expression? So basically that is this expression here. This one is actually the real part of the z to the n. So therefore our plan is to expand this one to the 4th power and take the real part of it and express it in terms to the power of cosine. And let's try to do it. So again, what we're going to do is that you have there the cosine theta plus I sine theta raised to the 4, and that is equal to the cosine 4 theta plus I sine 4 of your theta. So we can expand this one now, and again what we're only interested is to take the real part of the z to the 4, and that real part of z to the 4 is your cosine of 4 theta. For computation purposes, let's try to use cosine as c and imaginary sine is s. So we have the raised to the 4, and let's use the binomial expansion. So raised to the 4 for the binomial expansion is 1, 4, 6, 4, 1. Okay, so 1, 4, 6, 4, 1. So therefore that is cosine to the 4 plus 4 times cosine cubed times is plus 6 cosine squared is squared plus 4 cosine is raised to cube plus is to the 4. And again, we're only interested to something that is only the real part of this, something with real part. And where are those stuff? So we have this c to the 4th is real. This one is I squared, this becomes negative 1, that is real. This one is I to the 4th, which is actually real. This is is, so there's an I here. So this is imaginary part. This one is I cubed, so this is actually a negative I, so this is an imaginary part. We don't like that one. So therefore, our answer now will be equal to, let me just use equal to the cosine to the 4th minus, this is I squared is minus 6c squared s squared, and this is I to the 4th is positive, so plus s to the 4th. However, the question wants us to write our answer into the power of cosine. So how shall we do that? So we need to change all the sign here as cosine. So c to the 4 is equal to 6c squared. This is 1 minus c squared plus 1 minus c squared raised to 2. There you go. And then, what shall we do is to simplify that. C to the 4 minus 6c squared plus 6c to the 4th plus expand this one. 1 minus 2c squared plus c to the 4th. And simplifying this one further will give us c to the 4th, c to the 4th plus 6c to the 4th plus c to the 4th will give us 8c to the 4th. Negative 6c squared minus 2c squared will give us minus 8c squared. And this one will give you plus 1. And there you go. That is equal to 8 cosine to the 4 theta minus 8 cosine squared theta plus 1. Right? And that is the question. So then you have there your 3 marks for that. Right? So this one worth 3 marks. It's a lot of work and just few marks. So that's how further math question goes. Okay, let's proceed to part 2. If you have some question in the part 1, just try to replay the video until you would be able to understand everything. Alright? So verify without using calculator that cosine 4 theta is equal to the negative of cosine 3 theta. So again here, we don't need a calculator. We just need to plug in and we need to show that they are equal. So what is the plan is to plug in this theta there. So you have there cosine of 4 times 1 over 7 pi is equal to the negative of the cosine of 1 over 7 pi. I forgot the times 3. There's a times 3 there. So therefore, if we can show that the cosine of 4 pi over 7 is equal to the negative of the cosine of 3 pi over 7, then we are good. However, we are not allowed to use calculator. So therefore, what are we going to use is just a geometrical identities of trigonometry. So, how to show this one? Well, just try to remember your unit circle. Alright, I think my unit circle is a bit small, so I'll just draw it here for a while. Alright, so this is, for example, my unit circle. And again, what I want is to show this one, just for us to visualize it. So the cosine of 4 pi over 7, if that is your 0, and that is your pi, the cosine of 4 pi over 7 is actually here. Right? There's a, and the cosine has this value. So that's the value of your sine. I'm gonna use the green of your cosine, sorry. I'm gonna use this green portion there. And this one is actually numerically equal to that 3 pi over 7. It's just numerically equal, but of opposite direction. So of opposite direction like that. Okay? So therefore, how are we going to show that one? So therefore, in our question now, what we want to show is that the cosine of 4 pi over 7 is equal to the negative of cosine of 3 pi over 7. So how shall we do it? So the cosine of 4 pi over 7, that is actually equal to what? So the negative of the cosine of from 0, okay, wait, let me just adjust it. From 0 to pi minus this angle, minus that angle. So therefore there is no pi minus 4 pi over 7. Alright? And the 0 to pi minus this blue angle there will give you this 3 pi over 7. So 7 pi minus 4 pi over 7, then minus 4 pi over 7 will give you 3 pi over 7. Cosine negative. And there you go. So in your paper, you need to show this one, this part. Alright? And you need to do that one 4 times for each root. So for example here, So this is done. So we have shown this portion here. Alright? Now, sorry, this one. So let's try to show this 3 pi over 7. So if, for example, I just want to get a new paper. So what I want to show is that the cosine of 3 pi times 3 times 4 is 12. Cosine of 12 pi over 7 is equal to the negative of the cosine of 3 times 3 is 9 pi over 7. Again, we're only plugging in this to there. Alright? Now, how are we going to show this? So, again, just for you to have a visual of that, I just want to show that one visually. However, you really don't need to show that one visually if you can manage to write the trigonometric identities right away. So here, that is 12 pi over 7. 12, this is 0, that is pi. So that is now 0 to pi, there is 7 pi over 7. So 12 pi over 7 is somewhere here in quadrant 4. 12 pi over 7. And this 12 pi over 7 is the same cosine as here. And what is this one? That is actually your 2 pi over 7. And what we're going to show is that this one is equal to the cosine, to the negative of the cosine of 9 pi over 7. So 9 pi over 7 is here. So this portion is the cosine of 9 pi over 7 with respect to the triangle, right? And this one is the cosine of 12 pi over 7 with respect to the triangle. So how are we going to do that? So what shall we do from here is that the cosine, I don't know if it's visible, alright, still visible. So what we're going to do is that the cosine of 12 pi over 7 is actually equal to the cosine of 2 pi over 7, right? Because this is the same as, they share the same cosine there. But what is that equal to? That is equal to the cosine of pi plus 2 pi over 7. But what is that pi plus 2 pi over 7? Well, this negative of that, okay? So, what is that equal to? That is equal to the negative of the cosine of 9 pi over 7. And there you go. So that is your other solution. And then you also test this 5 pi over 7. So again, for 5 pi over 7, if your theta is 5 pi over 7, the cosine of 4 theta will be the cosine of 20 pi over 7. And that's, you need to show that it's equal to the negative of cosine of 3 times 5 is 15 pi over 7. Alright? So again, let's try to look at that visually. So let's try to look at that one visually. So you have there, so the 20 pi over 7, wait, it's not clear on the screen, there you go. So the cosine of 20 pi over 7, so it's somewhere here, right? So that is the 20 pi over 7, wherein this is 1 pi over 7. And this one is the same as pi over 7, okay? Like that. So the cosine, they share the same stuff. Okay, so this one, this two triangle is the same cosine there. And what you want to show is cosine 15 pi over 7. Where's that one? That is actually this one here. So what we're trying to show, that the cosine is the negative of this cosine here, of this angle, of this cosine 15 pi over 7, is similar to the cosine of 20 over 7. So that is not the point. So we can now say that the cosine of 20 pi over 7 is equal to the negative is equal to the cosine of pi over 7, and that is equal to the negative, okay, that is equal to the negative of the cosine of pi over 7. So you want 15 pi over 7. So that is this portion here. So therefore that is now equal to plus 2 pi. Plus 2 pi. Then that one will give you 15 pi over 7. Cosine of 15 pi over 7. That's negative. Now, you might be asking me, hey, how come we added 2 pi? How come we did not add pi? Because as you can see from here, if that is your pi over 7 there, okay, when you add pi, then you only have there 8 pi over 7, but what you want to show is 15 pi over 7. So therefore you need to add 2 pi, alright? So if you add 2 pi, that is 1 pi, 1 more rotation, so you're gonna return to this one here. Okay? So that's it. And the last one is that you need to show that the theta is equal to pi is also a solution. Again, that's a bit easy because you can show that the cosine of 4 pi is equal to the negative of the cosine of 3 pi. And how are you going to do that? So again, if you have that pi there, unit circle, okay, 4 pi is that 0 to 2 pi to 4 pi. So that is one there, okay? And this one is equal to the negative of your 1, alright? But what is this one here? That is actually this portion there, which is actually 2 pi, okay? Pi k pi there. So that is 1 pi, 2 pi, 3 pi. So that is equal to negative of the cosine of 3 pi. And there you go. It shows that the cosine of 4 pi is equal to the negative of cosine 3 pi. And let's proceed to the next part of the question. Okay? The next part of the question says, using the result cosine 3 theta equals 4, I think I need the upper part of it. Let me just have it, okay. I think, there you go. Okay, sorry. So using the result that the cosine 3 theta is equal to 4 cosine cube theta minus 3 cosine theta, alright, you need to show that the roots of the equation, okay, is this one, alright? So you have an expression for cosine to the 4 theta. And we have shown that the expression for cosine to the 4 theta is equal to this a while ago. So this one is your cosine to the 4 theta. And this one is your cosine 3 theta. So to show that the roots of the equation of this one is this, so as you can see, you have your 1 over 7 pi is that one. 3 pi over 7 is that, okay? So basically, if you will plug in cosine 4 theta, if you will change it with this one, and the cosine 3 theta, if you will change it with this, then you can actually get this one. So that is the plan. So let's try to do that. One moment, because my space is a little bit small. So you have there now, we want the cosine 4 theta is equal to that. So 8 cosine 4 theta minus 8 cosine squared theta plus 1. And that's equal to the negative of cosine 3 theta. The cosine 3 theta is given to me by this, 4 cosine cube theta minus 3 cosine theta. Okay, and then that is equal now to, wait, let me check, is it visible? Okay, sorry for that. So you have there now 8 cosine 4 theta minus 8 cosine squared theta plus 1. And then this one is moved to the other side there. So that is now plus 4 cosine cube theta minus 3 cosine theta. And there you go. So 8 cosine 4 theta, 8 cosine 4 theta, cosine cube is this, plus 4 cosine cube theta. And you have there now this, minus 8 cosine squared theta, minus 3 cosine theta, plus 1. And that's it. When you compare this one, when you compare that to this, they're actually the same. See, 8c4, right? You have their 4c cubed minus 8c squared minus 3 cosine plus 1 equals 0. So the root of this, based from our initial solution, the root of this is equal to this, cosine pi over 7, blah, 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 blah. Do you need to show this? No need, because it means it has been automatically shown from here that if these two are equal with each other, and if the value of theta is this, then the solution of this is the cosine of this. Okay? So, there you go. And the last one, by the way, this is 2 marks there. That is 2 marks. Deduce that the cosine of pi over 7 plus cosine of 2 pi over 7 plus cosine of 5 pi over 7 is equal to negative half. So as you can see, this one is actually the sum of your roots. Alright? So this is the sum of your roots. Now, how shall we do that? How shall we find the sum of the roots? I don't know if you still remember that you have, what do you call that one? The sum of the polynomials. So if you have the sum of the polynomials, what do you do? Sorry, the question says it's equal to, wait, let me just double check with the question. It says it's equal to 1 over 2. Alright. So meaning, when you add all the sums here, when you add all the sums, all the, what do you call it one? All the roots, okay? So this is now the summation, the sum of roots, okay? And what is the sum of the roots? Remember, if you have a polynomial, if you have polynomial ax to the fourth plus bx cubed plus cx squared plus dx plus e is equal to 0, we have said that the sigma of the roots is equal to the negative b over your a. Alright? And from here, you can see that the negative b over a, your b is that 4 there, and your a is that 1 there. So therefore, the negative b over a is negative 1 over 2. Alright? However, so this is now negative 1 over 2. However, that one is this one, cosine 1 over 7 pi plus cosine 3 pi over 7 plus cosine 5 pi over 7 plus the negative 1. Okay, plus the negative 1 is equal to the negative 1 over 2. But the question says we need to show that this portion is equal to 1/2. Okay, again, the negative b over a is the sigma of the roots, okay, which is equal to negative 4 over your 8. And that one, okay, and that one includes the negative 1. But the problem is just asking you that this portion here is equal to 1/2. So therefore, because negative 1 is included there, you need to add plus 1 there. So therefore, you can get that expression. Okay, so this is one of the examples for the Moivers theorem. I'm going to give you 2 more examples about it on the next video. If you don't understand the methodology that I used, maybe you need to review first the introduction to the Moivers theorem on the first video that I have created. Thank you very much.